Bismillahirrahmanirrahim. Welcome to the new lecture of data communication and networking, chapter number 5, part B. So today we are going to study about MFSK and PSK and their characteristic and some other relationships. So now we need to understand what is coherent and non-coherent. So coherent and non-coherent. So in a non-coherent FSK, frequency shift key scheme, when we change from one frequency to other, when we are going to change from one to another frequency, we do not adhere to the current phase of the signal. So what we can do in non-coherent, we do not adhere to the current phase. So it means we do not apply anything on the same phase. So we do not apply anything, so we do not adhere. So same like, so you can be like, let's say if you have this phase, so it's not necessary to apply the same phase in a non-coherent FSK, not necessary. Just you can say like it. In coherent FSK, the frequency switch from one to another frequency signal, so the switch from one frequency signal to the other only occur at the same phase. You can see here the thing is same phase, here is not necessary about the same phase. Okay, so just it's a bit different about coherent and non-coherent FSK. So multi-level FSK, or we can say MFSK. So similarly to ASK, FSK can be used multiple bits per signal element. Just simple number of bit can be used for a single signal element. So and that mean we need to provision for a multiple frequency, each one to represent a group of a data bit. So the bandwidth for FSK can be higher, like this is the formula for the bandwidth of FSK. You can be see it here. So if you can see the figure 5.7 bandwidth of MFSK, let's see this is your digital signal, digital data. This is your modulation or a carrier frequency. There we are carrier. So now digital signal is going to be added with the carrier. So what happened? That once we have a 1, so we have a higher frequency. I told you. Once we have a 0, we have a lower frequency. Then we have a 1, we have a higher frequency. Then we have a 1 high frequency. Then we have a 0, we have a low frequency. Low frequency means number of a cell is going to be reduced. If you can see here is a 1 2 3 4, we have a 4 cycle, mean our frequency is 4 Hz. Here is 1 and 2. Here is f is equal to 2. So the overlapping of digital signal with the carrier, the result is this one. So the frequency will going to be increased. Once we have a 1 bits bit 1, once we have a 0, then the frequency is going to be reduced. Like we have a, this is your digital signal. Then we have VCO. What is VCO? VCO means voltage control oscillator. So what's going to be happen? Voltage control oscillator, you have a carrier. This is your carrier. Let's see, this carrier will be here. I'm going to be draw it well. Let's see, this is your carrier, like carrier. So this VCO will control this frequency once carrier is added with the digital signal, and your result will be like a smooth waveform. Okay, so this is the basically the concept behind MFSK and FSK. So let's come to the example 5.6. we need to send 3 bits at a time with a bit rate of a 3 megabit per second, and the carrier frequency is 10 megahertz. Calculate the number of level and the baud rate and the bandwidth. So simple is how many bits we have. So this is your formula, L is equal to raised to power n, and it's 3, so it's your how many level? 8. Okay, the second is the baud rate. So the baud rate is S is equal to 3 Mbps divided by 3. You know about this formula, n multiply with 1 divided by r. So what is your n? What is your bit rate? Bit rate is 3 Mbps. So bit rate is 3 Mbps, and how much is your r? Is 3 bit per signal. So 1 over 3. So you simply put it out. r is number of a bit per signal, so we have a 3 bit and one signal element, so r will be 3, so it will be 1 over 3 multiply with, so your baud rate is 1 megahertz, your baud rate is 1 megabaud. Okay, so your baud rate is 1 megabaud. So what we can conclude from this? We can conclude that then when our baud rate is 1 megabaud, then we can say that our carrier frequency need to be 1 megahertz. Once we say 10 megahertz, so 10 megahertz frequency means you are using all the carrier at the one point. So that's why we can say, due to this we can say that our carrier frequency must be 1 megahertz. Okay, so apart in a formula we use 2 del f, so it need to be 1 megahertz. So coming to, so baud rate is noun and when megabaud is noun, just keep in mind the carrier frequency is 1 megahertz. So need to find the bandwidth. So for a bandwidth you need to be keep in mind, so we have carrier frequency, which is 1 megahertz, and we have a number of a level. So number of a level multiply with the carrier, so it will be 8 MB, 8 megabyte. So your bandwidth is 8 megabyte. So let's see, come to this graph. So you will be this block diagram. So in block diagram, if you can see, our carrier frequency always be a central frequency. So 10 megahertz is basically our carrier frequency. So this is basically our central frequency. And how much is our bandwidth? Our bandwidth is 10 megahertz. So it means we are using duplex communication. In a duplex communication, we need to have a carrier frequency center. So go to this way with the 4 and go to second way. So it need to be 4 megahertz this way and 4 megahertz this way. Okay, so the thing we need to have here, we have a 8 different carrier frequency. So for finding a 8 different frequency, let's see, this is our point, this is point. So let's see 10 and 11, we have a 10 11. So what should be the carrier between 10 and 11? It will be 10.5. so 11 and 12, so what will be the your carrier frequency between 11 and 12? 11.5. so how much we have a carrier frequency? 1 2 3 4 5 6 7 8. So we have another 8 carrier frequency which is used for a duplex communication. So that's why we say that, why we taking 1 megahertz, because our carrier frequency is 1 megahertz now. So our carrier frequency 1 megahertz, so we are taking 1 megahertz difference between the carrier frequency. Okay, so this is basically a method how we can utilize the bandwidth. Once you are purchasing a bandwidth from satellite communication, so once you receive the bandwidth from satellite, so you can manage by your own. So this is the method which we are going to be arrange for ourselves. Okay, so now coming to phase shift key, so we vary the phase shift of the carrier signal to represent digital data. Bandwidth required B will be 1 plus D multiplied with the S. PSK is much more robust than ASK, as it is not that vulnerable to a noise which change amplitude of the signal. So this is a bit robust than ASK. So now coming to the block diagram of the graph, then we will be see here. So in a graph, if you can see that once we have 1, so we have the communication. So in a phase shift key, so for a 1, let's see our angle is 0. Okay, or start from is this point. Once we receive to the another data or a bit, and this bit will be 0, so the phase is going to be shift. Once there, let's see, once there is 90, there will be 270. Like you have a 0, let's see, we have 0, its opposite is 180. Once we have a 90, its opposite is 270. Okay, like so on. Okay, so once for 1 it start from upper position, for a 0 it's come down, because bit is going to be changed from 1 to 0. Then when see once it reach to be here, and what we have 1, so for a 1 it's going to be shift the phase, then one same phase, but again once we have a 0 bit it's going to be shift the phase. So in the phase shift we are just changing the phase by changing a bit. Once a bit is going to be changed, so it means the phase is going to be changed. Again the same thing, we have a 1 data with the 1 signal element, so our OR will be 1, and again the bit rate is, again your baud rate is 5 and your bit rate is 5, because 1 2 3 4 5 you have a 5 bits per second and you have a 5 baud. Okay, so both again same, and the bandwidth for the phase shift key is same like ASK, so not a bit change. Okay, so what is the comparison between phase shift key and amplitude shift? In a phase shift key we are just changing the phase, which is not to be easy for communication, but in a amplitude shift key where we were changing the amplitude of the signal, like an amplitude of an amplitude shift key, for a 1 we have a high amplitude and for a 0 we have a 0 amplitude, but in a phase shift key for a 1 we have a one phase and for a 0 we have another phase. So it means once you are transmitting your signal, your data, your digital data, so once the bit is going to be changed, so you need to be shift your phase from one to another phase. So this is a basic comparison between ASK and PSK. So once we can see this black diagram of binary amplitude shift key. This is binary amplitude shift key. Okay, again we have a digital data and signal, we have a carrier, digital data and signal is going to be add, is going to be multiplied with the carrier, and at the result what here we are going to do. So this is phase shift key. What we are going to do, the phase of the signal is going to be changed. Let's see, one up to 1 we have a this thing. Okay, once we have a 0, so the phase is going to be changed, then up to this point it's going to be this one. So once we have a 1, so the phase will be going to up. Now it's not going to be like this, actually it need to be like this one, but it's not, because 1 is here, so it's going to be up. Again for a 1 it will be same, for a 0 it's going to be shift the phase. So this is not BSK, this is called BPSK, binary phase shift key. Okay, so the black diagram, let's see, we have a digital signal, digital data, we have a carrier, oscillator can create a carrier, then we have a multiplier, so this data and carrier will going to be add here, then at the end we have a analog signal. But keep in mind, up to now as we studied, so this thing is happen at the sender side. Okay, and we can say this is this is a modulation. Once the carrier is going to be added with the digital signal, that's called modulation. Okay, what is the basic definition of modulation? The basic definition of modulation is once the phase, frequency or amplitude of your original signal is going to change, it means your signal is going to be modulated. This is the definition of modulation. So now coming to the quadrature PSK or QPSK. So one thing keep in mind, once we need to increase the bit rate, so what we are going to do, we can code 2 or more bit onto one signal element. Let's see, this is our signal element. Okay, initially we just have a 1 bit for signal, but if we want to increase our bit rate, so we need to code 2 3 more 4 5 number of a bit can be coded on a one signal element. One thing more, once our bit rate is going to increase, it means once we are coding 2 or more bit in one signal element, so it means our baud rate or our signal rate is going to reduce. Keep in mind why. Let's see, once we have 1 bit, once we have a 1 bit, let's see, 1 bit, then 1 bit, like this is 1 bit. Okay, so our signal element is going to be increased. But once we have a 2 bit, so let's see, we have a 2 bit, this is basically a bits. Okay, once we have a 2 bits, so this 2 bit will be 1, this 2 bit in a one signal element, this 2 bit 1 bit. So what's going to do, what we are going to do, we are reducing the signal rate, or we are going to reduce our baud rate. Okay, this is basically a concept behind the QPSK, and this is the basic advantage of it. So in QPSK, we parallelize the bit stream so that every 2 incoming bit are split up, and PSK a carrier frequency. One carrier frequency is phase shift 90° from other in the quadrature. So one thing, once you have a 2 bit, so you have a combination of a 0 0, then 0 1, 1 0, and 1 1. This is your combination. So what is the basic thing? He's saying that the one carrier, this is a one carrier, this one carrier is going to be shift from this to this, so it will change by angle of 90. Let's say that we can say that our signal start from this point. Okay, then when it's reached with this one, we can say it will be shift by angle of a 90, and it will start from this. Simple as thing. So that's why we are saying that it will shift the phase by angle of 90 in a quadrature. So the two PSK signal are then added to produce one of 4 signal element. So how? Okay, so one thing, give it 2 PSK signals. Okay, 2 PSK signal are then added to produce one of 4 signal elements. So I will show you in a graph now. So how many level we have? 4. So how it can be 4? Because we are taking 2 bits, so 2 raised to power 2 is 4, so it means 4 level. Okay, so again the same one, 0 0 1 0 0 1 and 1 1. Okay, this is our data now with the form of 0 1 1. So what we are going to do, let's see, in this block diagram we receive 2 composite signal. We receive 2 it's a composite signal because we are adding 1 2. So once we are adding more, once we are adding more than one signal, so that's called composite. So this is our digital signal. Okay, simple. And this is our carrier, digital signal and carrier. So digital signal is going to be multiply with the carrier. Digital signal is going to multiply with the carrier. Just keep in mind, multiply with carrier. So what's going to do? So it start, let's see, it start from this point 0 up to this. Okay, then what we have 1 R. What we have 1 0. Once the bit is going to be changed from 0 0 to 1 0, so it's going to be changed by angle of 90, by angle of 90. So it make an angle of 90. Then again it is going to be changed, the bit is going to be changed again, so again it will going to be change the angle by 90. Again it's going to be change angle by 90. So again, if you can see here, 90. Then it's going to be change the bit, so again it's going to be change the bit by 90. But just keep in mind, we are just taking a 2 bit at the same time. This is a quadrature, and in a quadrature phase shift key, once the bit is going to be changed, so the when bit is going to be changed, so the phase will going to be changed by angle of 90, angle of 90. Okay, this is the first method, this is the first graph, this is the first graph. Okay, once then come to this one, you have a 0 0 and 1 1. Okay, so just keep in mind 1 0 0 1. So this is your carrier. Again 0 0 up to this level you have a same, up to this level we have the same graph. But what happen again, one bit is going to be changed, so it means it's going to be changed by angle of 90. So what does it mean? So what does by it mean that, so what we are going to conclude that once this signal and this signal both are going to be add now, both are going to be add now, at the result we get this signal. This is our result now, this is our result now, which have a, like, see, in this point, then see there is a change of 90 angle. Okay, then reach to this one in difference of a 90 angle, difference of a 90 angle, and so on. Okay, let's come to this one now. We have a 2 by 1 converter. You just say 2 by 1 mean we have a 2 signal and convert it to 1. Okay, then this is 1, this is another signal. Okay, so once this signal is going to be multiplied with the carrier here, and this signal is going to multiply here with the carrier. So once, just keep in mind, once, because we have oscillator here. Okay, this is a basic, this oscillator can create a carrier. So once this signal and the carrier signal and the bit is going to be changed, so what happened at the end? So it's going to be change the signal by angle of 90. So once this signal is going to this way, okay, so once it's going to be this way, so it's going to check the oscillator. Okay, it's the bit is going to be changed. Okay, shifted by angle of 90. Once this is coming to here, okay, this is a signal. Okay, shifted by 90. Okay, so this is a basic thing. So at the result we have a this signal and this signal, so we have a 2 signal and we have a 2 by 1 converter. So at the end we are going to be sum both of it. Once we are going to be sum it, so we will receive this signal, and which is the our final signal. Okay, but in quadrature, just keep in mind we just eat 2 or more bits and shift the phase by angle of 90. So coming to example 5.7, find the bandwidth for a signal transmitting at a 12 Mbps for a QPSK. The value of it is 0. QPSK means 2 bits. So for a QPSK means 2 bit is carried by one signal element. So one thing keep in mind, always QPSK means you always have a 2 bit. You can more than 2, but keep in mind just have a 2 bit. So this means that R is equal to 2 bit per signal element. So it means your R will be 2. So the signal rate or the baud rate is S is n multiplied with the R. So it's going to be, how much is your bit rate? 12 Mbps. This is going to be 2. So divide by 2, it's going to be 6 megabaud. Sure. So your signal rate, your baud rate is 6 megabaud. So with the value of d is equal to 0, so you have a formula of a bandwidth. So you use the formula of a bandwidth for a QPSK and you will got your bandwidth. Okay, so coming to the constellation diagram, which is simple one. A constellation diagram help us to define the amplitude and phase of the signal when we are using two carrier. One is quadrature of the other, like the x-axis represent in a phase and carrier, and y-axis represent the quadrature. Let's see this example, this black diagram. So in a y-axis we have a quadrature carrier, in axis we have in phase carrier, and this point show the signal element, this point show the signal element. So just once we have a signal element, so signal element can show you the number of a bit, signal element can show how many signal element you have. But this is simple a concept of constellation diagram. It just compare the amplitude quadrature component and in phase component. Okay, so now you can see three constellation diagram. So once we have an amplitude shift key, so for amplitude shift key we just have a one amplitude, for a 1 we have an amplitude, for a 0 we don't have a amplitude. So coming to B, so in ASK we just only have a one amplitude, so bind is 0. So once we have a 0, so 0 have a 0 amplitude, that's why it will be on this point. And so we can say like that the 2 points should be on the same axis. Coming to the BPSK, binary phase shift key. So in a BPSK, if you can see, in BPSK we just change the phase of the signal. Okay, so once we have a phase with the 1, for a 0 it will going to be changed. So what is going to be, have a 2 amplitude, one amplitude is +1, another is -1, so it means we have a 2 amplitude, 1. And the one and another thing which is important for it, for amplitude +1 it means it starts from 0 angle, and for amplitude -1 it means your signal start from angle 180. So this is this simple, that's why this is plus, this axis is plus, this axis is minus. So this is angle is 0, this angle is 180. So this is the bit differentiation between BPSK and ASK. Okay, but both or the same axis. Okay, now coming to the C, QPSK. In a QPSK, keep in mind first we have a 2 bit, so 2 bit 0 0 0 1 1 0 and 1 1. So once we have 1 1, it means our both amplitude is 1 1, both amplitude of a signal is 1 1, so we have a this point. Okay, once we have a 0 1, one amplitude is 0, another is 1, so we have a this point for both 0 0, this one and this one. So in a QPSK we use two carrier. Keep in mind, before I show you in a block diagram, we use two carrier, and both the carrier, both carrier, one carrier in a phase and the other is quadrature. Quadrature means, let's see, you can see here now what is the difference between angle is 90 99, so this means both are quadrature. So once you need to be make a constellation diagram based on ASK, PSK and QPSK. So this is a simple method. So it not be necessary that you get just draw it like this. You can use 0 0 here, 1 0 here, 1 1 here and 0 1 here. So it's up to you, but just keep in mind that the difference between the angle, the how many carrier is using here and how many carrier using here. So this is a basic differentiation in a 3 constellation diagram. So for your information, that quadrature amplitude modulation. Quadrature amplitude modulation is a combination of ASK and PSK. Because we study QPSK, so it's a QAM. So once quadrature amplitude modulation, this is based on modulation, not key. Okay, so quadrature amplitude modulation is the combination of ASK and PSK. So constellation diagram for some quadrature amplitude modulation. One thing why we are not using a combination of ASK and PSK, because in ASK and PSK, when we are going to combine both of them, so there is a difficulty of phase shift. We are having a 2 carrier. Once we have a 2 carrier, it means one carrier will be quadrature with other, one will be in phase and another will be in a quadrature. So that's why we are not using that concept. So we are using this concept. So one in a figure A, 4 QAM. 4 QAM means we have a 4 different signal element type, 4 different signal elements. So this is a simple one, just like a, you can say it's just like a ASK, simple like ASK, amplitude shift key. Okay, then coming to Q4 QAM. In a 4 QAM, it's just like a quadrature phase shift key, same like for quadrature phase shift key, if you can see. But in a 4 QAM, in this one and this one is not 4, this is just simple QAM, or can we use QAM 4. Okay, so in this what we can say, that both the level are positive, both the level of modulation is positive, level or positive. Here just like quadrature can be positive, can be negative, it can be always be positive. So it can be that both the level are positive. Now coming to 16 QAM. So 16 QAM, in 16 QAM it shows that how many level we have a 8 level. How, like say 1 2 3 4, 4 will be positive and 4 will be negative. So 16 can show as 8 level, and you know about a level, once we are going to increase our level, so bit rate is going to be increased and so on. Okay, so this 16 can just give us the easiest way of transferring our digital data into analog by, because our number of a level is going to increase. It means like we have for a 1 we have 0, 0, for a 0 0 we have a this, for a 0 1 this, for a 1 1 this, like this one is like this one. So this is the basic advantage of a 16 QAM. So in a QAM, just keep in mind there is just game of shifting a amplitude, just changing the amplitude. Okay, so in this case, in a quadrature amplitude modulation, if you can see, we can have a positive voltage, we can have a negative voltage. Okay, positive and negative. So when we have a positive negative, and we will have a more benefit in our hand, we can transfer our data, because we have a 1 and 0. So 1 and 0 like this one, this is your so 1 and 0. Once you are going to increase our level, so it's going to be more better for us. So, and this was your lecture, and hope you guys will find it well. For your information, once you have any question, kindly raise your question in the comments, so I will try to be answered at there. So thank you for your time. See you in a next lecture.